Now we're going to talk about functions, and functions are extremely useful in your code because they make your code modular, reusable, and a lot cleaner. So functions actually are going to be the first thing that we're going to deal with that will be able to change things programmatically. So functions can deal with logic, functions can store properties, functions can do a lot of things, and the best way to really get started is just to jump into a playground and show you what they're all about. So let's do that. Okay, so functions. Let's start out with functions by showing you how to actually create a function, and I'll explain the syntax as we go. So basically you start out with the func keyword. That means you're about to declare a function, and you give it a name. And this function I'm going to say hello, and then you have these parentheses, and inside those parentheses would be any arguments that the function takes. So in other words, if you needed a string from the user, that's where you would get it. And then if you're returning anything in a function, then you use the hyphen and the greater than symbol to create this arrow, and then you say what type you're going to return. So in this case we're going to return a string, and then you open up your block for your function. Okay, and then in here what you have to do, the reason we're getting that error right off the bat is because we have not returned a string. There's a keyword called return, and we use that to inevitably at the end of the function we're going to return a string because we said that we're going to return a string when we wrote this function. So literally all this function is going to do is going to return the string hello, and that's it. That is all this function does. Now you'll notice that nothing has happened, and the reason is because we haven't called the function yet. And how do you call a function in Swift? Well, you just type it out in a playground, string hello, and then you'll see that on the right hand side it returns exactly what we would expect, hello. So that's pretty neat. That shows you the makeup of a function, but it's not really useful. All it does is say hello, and we can't change what it says or anything. So let's make a better function. So we're going to create a function with the func keyword, and we're going to say hello there, and that's going to accept an argument which we're going to call name, and that's going to be of the type string, and then we're going to close our parentheses because that's all we're going to do. We're going to take a name, and then this is going to return a string, and we'll just open up our function block here. And now what we'll do is we're simply going to do the same thing basically as we did in the above function, but it's going to be a little bit more dynamic. So we're going to return a string that says hello there, and then we're going to pull out that name variable that we just created. Alright, so now again you don't see anything because we haven't called it, but if we call hello there, you'll notice that it prompts for a string, and it's saying that it wants a name. So I'm going to say class as the name, and you'll see that when I go ahead and I call that function, that returns the string hello there class. So that's pretty cool. Still doesn't do all that much, so let's do a function that deals with math a little bit here. So we'll call this function add, and we'll have that accept a number 1, which is going to be an integer, and a number 2, which is going to also be an integer, and that's just going to return an integer. So when someone puts a number in, we're expecting to return the integer, so we're just going to return number 1 plus number 2. Alright, so this is just really just getting your feet wet with functions a little bit. So when we call this function add, it asks for a number, and it tells you that that's going to be an integer. So we'll say 345, and if you hit the tab button it goes over to the next one, and it asks for number 2, so we'll just use some off-the-wall number, and on the right hand side it evaluates that, it adds those together, and it does return our integer like we expected. Now, we could have had that return a string that said, 345 plus 856 equals 9101. But we just, for simplicity's sake, we just return an integer there. So I want to get into slightly more complex functions, but I'm going to do that in the next video. I really just wanted to introduce you to the syntax of a function and let you understand how it actually works. Now, notice when we called this add function, there is a variable up here that we were asking for, and it's called number1. And notice that it doesn't say number1 like it says number2 here. And the reason for that is the first argument in a function, you're expected to understand what it is because of the name that you've given your function. So make sure you give your functions good names. Now, you'll notice as we called it before, it still does say that we want that number, but it doesn't specify it when you actually type out the function. Okay, so there's no need to really be worried too much about it. But in the next video, I want to go into a little more in depth on functions and just show you slightly more complex functions that maybe store some properties or deal with some properties or perhaps handle some logic before they return a statement. All right, so we'll see you there. Okay, so in this video we're going to take a closer look at functions and look at a couple more complex examples. So we're going to jump back to that same playground we were working with, and we'll take it from there. Okay, so we're back in the same playground, and I've just created a little bit of room here so we could work and not be staring at the bottom of the screen the whole time. So we're going to create a slightly more in-depth function just so I can show you their potential a little bit. So I'm going to say func, and we'll make this area, and it's going to take two numbers. One is going to be width, which is going to be an integer, and the other is going to be height, which is also going to be an integer. And then what we're going to do is we're going to return a string. So we'll open up our function area here, and what I'm going to do is I'm going to create a variable, and I'm going to say let result equal width times height. Okay, and then we're going to create a little logic in here. So we're going to put an if statement in here, and we're going to say if width is equal to height, then we're going to do the following, and we're going to go ahead and return this string that says the square is, and we'll pull out our result, square inches. Okay, so that's what we're going to return if they're the same. So if the width and the height are the same, obviously it's a square, and otherwise, so else, if they're not the same, then we're going to return something else, and we're going to return the string that the rectangle is, and we'll pull our result out again, square inches. Okay, so now watch what happens when we call this function here. So I'm just going to call it here, and we'll call area, and it's going to ask me for a width, which is an integer, and I'll say that the width is 36, so 3 feet, and the height is, we'll say 80 inches. And then what it'll tell me is the rectangle is 2,880 square inches. Okay, but now if I call it again and I say 25 and 25, then it detects that that's a square and shows me that the square is 625 inches. Okay, so you can put logic into your functions and make them actually do the work for you. So, and we could make this work for circles. We could make it work for triangles. We could do all sorts of things, as complex as we'd like to make it. As long as we know how to put it in terms that the computer will understand, then it can be done with a function. So let's take a look at another slightly more in-depth example. So we're going to make a function that basically says to turn off an appliance or not. So we're going to actually call it turn off appliance. So we'll say func turn off appliance. And that's going to take two arguments. One is going to be the appliance as a name, so a string. And one is going to be is on, and that's going to be a Boolean, so a true or false. Now, even though this may be slightly more in depth of an example, it's not going to return anything. So as we are right now, we have absolutely no errors. But what we're going to do is we're going to do a if statement based on is on. So we could say if is on equals true, but whenever you evaluate a Boolean, you don't really need to say is true, because if you're saying if is on, then you're expecting to determine whether that's true or not. So if is on, then what we're going to do is we're just going to print a line, and it's going to say the and we'll pull out the appliance name. So the appliance is on. Please turn it off. Okay? And then otherwise, we'll say else. If the appliance is if the is on value is false, then we're going to return a different statement. But you have to try to kind of visualize that what we're doing is just returning a statement here, but in reality what we would be doing is we would actually be sending a signal to the device to turn the appliance off, or we would be ignoring it. So if we go ahead and call this down here and we say turn off appliance, and we say that it's an oven and is on is true, then what it'll do is it'll just say the oven is on, please turn it off, but it won't say it down here because all we're doing is a print statement. If I had done a return line as a string, it would show it down here also. But it's saying the oven is on, please turn it off. And instead of actually just saying that, what we would do in a real world application is we would send the signal to the oven to turn it off. So if we see that the oven is on, and we just press a button on our watch or on our iPhone to turn it off. And you can do stuff like that with HomeKit, with certain appliances in HomeKit. So it's not something out of this world that can't be done. It's something that's very reasonable. So that's just another example of what you could do, and you have to kind of use your imagination to see this working, but it's a good example because it shows that not only can you go based off of a Boolean here, but this Boolean is on doesn't have to come from what we put in the function. It could come from a variable that is detected from the appliance. So if the appliance is on, it sends a signal, and then when we say oven, we're just going to go check the status of the oven, and if it is on, then we're going to go ahead and send a signal to turn it off. So, and otherwise we're just going to ignore it because it's already off. And you wouldn't want to turn a oven on remotely, so we're not going to worry about turning it on. Okay? So, I mean, those are, maybe not extremely in-depth examples, but those are enough to get us started and well on our way to understanding functions, and definitely understanding them enough to create some pretty cool stuff in the applications that we're going to look at. And the functions that we're going to deal with in the applications are going to be, in fact, more in depth than these. These are just, some pretty rudimentary examples, as you might expect in learning functions for the first time. So hopefully you understand all this. I encourage you, not only on functions, but on the other sections of the classes, to go ahead and play around with the code and try to make your own functions and make your own classes as we get into classes and whatnot, to make your own and really experiment with it until you really fully understand what's going on, because that's really how you learn, and that's going to be one key part of your success as a app developer. All right, so we'll see you in the next lesson. In this video, we're going to talk about optionals, and optionals in Swift tend to confuse a lot of people. But all an optional really is a variable that may have a value or it may have no value at all. So it either has a value or it has no value at all. So I think if explained correctly, then optionals aren't that hard to grasp, and I'm going to do my very best to explain it to you in layman's terms, because optionals are used quite extensively in a lot of the frameworks that we deal with. So you kind of can't avoid using optionals, and I'm going to try to show you like a real world scenario where you would use an optional. Okay, so we'll get to that. Let's go to a new playground. Okay, so to help me explain optionals, I'm going to use the weather. So I'm going to create a variable called temperature, and it's just going to shorten it for temp, and that's going to be of the type double, and I'm going to put a question mark here so that that's now an optional. And you see, if I don't give that a value to begin with, on the right hand side it gets the value of nil, which means it has no value. Okay, so basically what we would do, because there's no way to predict the weather, is we need to go ahead and connect to the internet to get the temperature, right? But there's no surefire thing saying that we're going to get the temperature. But let's just say we did in fact get the temperature, and it is 78.5 degrees out. Okay, now what do we do with that? Because this could come back as having no value. If it comes back as having no value, if it comes back as nil, then you're going to crash your program. So you need to take precautions to do that. So the most rudimentary way to do that would be an if statement. So we could say if temp is not equal nil, then what we would do is we would do a print line, and we would say the temperature is whatever the temperature is. So we would say the temperature is, and we would pull out temp to go ahead and display that. And then otherwise, if the temperature is nil, then we would say else, and we would do another print line, and we would say the temperature could not be obtained. So for whatever reason, we can't get to the temperature. So as you see, it's following correctly because we do have a value for temperature right now. It's 78.5 degrees. But if I comment this out, then it will go ahead and say that the temperature could not be obtained. Now the problem we run into here is if I back this back up and we look at the actual output here, it says the temperature is optional 78.5. And that's not going to do us any good because we don't want that word optional in there. So the only way to handle that in this case would be to put an exclamation point there saying that there's definitely a temperature, definitely a value in the temperature field. Now, if I go ahead and comment this out, it goes down to temperature could not be obtained, and if I uncomment it, it comes back to temperature is 78.5. And this really is a safe way to do it because you're checking if temperature is nil first. But this exclamation point, if it goes ahead and unwraps that, that's called forced unwrapping, by the way. That's what that exclamation point means when you're dealing with an optional. It's a forced unwrap. It means that there's definitely a value there. You know there's a value there, so show it to me. Now, if it does force unwrap that and it turns out that it is nil, as I said before, it will crash your program. Now in this case we are kind of safe, but there's a much better way to handle it, and I'm going to show you that next. So it would be much better and much more elegant if we used an if-let statement, and this is called optional binding. So if I say if let and I create a variable and I just call it the temp for simplicity, if I can let the temp equal temp, then I'm going to do the following, and that's going to be to go ahead and print that line that the temperature is, and then pull out the temperature. But instead of pulling out temp, we pull out the temp. Okay? So now we don't have any optionals to deal with. We don't have any unwrapping, forced unwrapping going on. So otherwise, if it can't assign that variable, basically, then we're going to print out that we could not get the temperature. Okay. All right. So basically, if it can assign that, then it's going to go ahead and run this first code. If it can't, it's going to go into the else statement and it's going to run this second code. Now, if I were to comment out the actual temperature here, so now we're not getting it, then you'll notice that in both cases, the if else statement and the if let statement, it's both saying that we could not get the temperature. But even if I didn't have this here, then this would still give us the safety. It would just not do anything, because if it can't assign this to the value of this and have that be something other than nil, this will never print. Okay, so let me show you how unsafe it is to actually, I'm going to uncomment this out real quick so we can actually get through this without an error. I want to show you how unsafe it is. So I'm going to create a variable called the weather, and it's going to be a string, and it's going to say the temperature is, and we're going to pull out the value for temperature, degrees. Okay, so now it says optional degrees, so that's no good. So what's the only other way that we could handle this is to go ahead and put an exclamation point, right? Okay, great, well that worked. But now what happens if we don't get the temperature from the internet? Boom, your program crashes because it can't get the temperature. Now you notice in these two instances up top, it's fine, but when we're down here and we're just simply pulling it out and saying, go ahead, give me that value, I know it's there, and then it's not, then you have a big problem and your program crashes. And first of all, Apple checks programs pretty extensively, and if your program does crash, it's not ever going to get into the App Store, number one. But number two, even worse, is your user has the app and all they're doing is trying to check the weather and it crashes on them. How many times do you think they're going to try to run that app? So this, not a good way to go. The other two options are okay. Definitely veer towards this, where you're doing the if-let syntax, okay? Because that's much more safer. You don't have to deal with any forced unwrapping, and you're good to go, and your program does not crash. So make sure you understand this before you move on. Okay, so we're going to talk about enumerations, and an enumeration is basically a list of everything in a set or collection. And in programming in Swift and other languages, enumerations do just that. They narrow down the options that can be selected within a certain field or within a certain element. Okay, so that's what we're going to be talking about. So let's jump over to a playground and get started. So let me start by saying that enumerations in Swift and in programming are all over the place. You really can't avoid them. So just to show you how this is done, I'm just going to import UIKit here, which is the framework for iOS, and I'm going to make a couple variables here. So I'm going to say let keyboard type, and I'm going to set that equal to a UI keyboard type. And then this is an enumeration, so if I hit period here, then I can only select certain keyboard types. And we're going to say that this is going to be a number pad. Okay, so Then I can also, go through this framework and say I'm going to set the keyboard style. And if I set that to a UI keyboard style, appearance rather, and then you see we only have limited options, and that's the whole point of an enumeration, is that it's kind of a fail-safe. You can't mess up too much. Okay? And the whole idea when you make your own is that you can't have errors in your program due to improper user selections or things like that, because it's either one selection which is correct, or it's one of the other selections which are all correct and verified by you before it ever gets into the user's hands. So let's take a look at how we make an enumeration. So we start off with the enum keyword, so enum, and that signifies that we're going to be declaring an enumeration. And then we give it a name, so I'm going to say seat preference. And then we open up a code block, and in here is where we would put our enumerations. Now, note the capitalization, because enumerations are started with a capital letter. So it's still camel case, but it starts with a capital letter, and you'll see this quite a bit now that we're getting a little bit further into the course, because there's other elements that are started with a capital letter, like classes and structures and things like that. But back to seat preference, this is sort of like a switch where we have cases. So we use the case keyword, and in this case, one of them is going to be window, and then we'll make one for the aisle, and then we'll do another case for a middle seat, and then finally we'll do a case for no preference. Okay, so now we have an enumeration. Enumeration on its own, in general, doesn't do a whole lot. So they kind of have to be used in conjunction with something, and they're very powerful if used with a switch statement. So the first thing we would do is we would create a variable. So I'm going to create a variable, and I'm going to call it customer prefers, and I'm going to make that of the type seat preference. Okay, now what I can do is I can go ahead and say customer prefers and just set that equal to a seat preference dot middle, let's say. But you see how I'm just giving those options? So it only gives me those options to select from the seat preference that we've defined. So I'm going to say aisle, but the cool thing about this is that we don't actually need to do that much typing, because we said this already as the type of seat preference. So all we really need to do is say dot aisle, and that will go ahead and set that preference for us. Okay, so now let's learn how to use a switch statement with this. So we would do a switch, and we're going to go off the customer prefers variable, and we're going to put our switch code in here. Okay, so as you recall, when we do switch statements, we use cases. Now I know this looks a little familiar because we're using cases up top, but recall that the syntax for a case on a switch is slightly different than the syntax for a enumeration. So we would say case, and we would just go down the line. So we would say dot window, and don't forget to put your colon here, because you need it in a switch statement and you don't need it in the enumeration itself. And then in this case, we're just going to go ahead and print a line, and it's going to say customer prefers the window seat. All right, and then notice the error that we're getting here, and that's because switch statements have to be completely exhaustive. Okay, but you'll notice that Swift is smart enough to know when it's exhausted all possibilities. So once we've put these 4 cases in, then it will in fact go ahead and eliminate our error. So we're just going to do the same thing here. We're just going to print, the customer prefers the aisle seat. Yeah, customer prefers the aisle seat for aisle, and then we'll make another case for middle, and in that case we're just again going to print a line. Customer prefers the middle seat, and we're still going to have an error. So now once we put this case for no preference, and we have to spell it right, now our error will go away once we have this as a full statement. And it thinks it's a full statement because I have an empty string in there, but we're just going to say customer has no preference. Okay, but you'll see here that the switch statement is automatically evaluating customer prefers because we've assigned it the .aisle enumeration. Okay, so it says customer prefers the window seat, or the aisle seat rather. All right, so I'm not going to get too heavy into enumerations right now because we are going to deal with them quite a bit as we go through the course. And in fact, enumerations can be used in the new error handling syntax, which is coming up in the next video. So we're going to talk about error handling next, and you'll probably see me give you an example with an enumeration. Okay, so that's enumerations. That's just the basic tip of the iceberg type of enumeration, but we'll get into more depth as we go throughout the course because we're going to need to. All right, we'll see you in the next video. Okay, now we're going to talk about error handling, and error handling in Swift 2.0 is highly improved upon versus error handling in Swift 1 and Swift 1.2. So there's a lot to learn here. So we're going to be using enumerations, and we're also going to be using a function that throws an error. We're going to take a look at the new guard syntax, which is a safety feature for your code. And we're going to also learn the do, try, catch syntax to handle errors. Okay, so there's a lot to learn in this section, and best way is just to get started. So we're going to jump over into a playground and take a look at error handling. So what's the best way to handle an error? Well, not have an error at all, but that's not going to happen because not everything is in our control as a programmer. Anything can happen. You can have internet outage, you could have a database failure, you could have corrupt system file, you know, any number of things could happen. So we need to be prepared to handle an error if one occurs. So in Swift 2.0 they introduced error handling, a new guard syntax, and a do try catch statement that will help us handle errors in the event that we have them, and we can predict if they're going to happen and be ready to handle that in our code. So the first thing I'm going to do is I'm going to create an enumeration, so an enum, which we just looked at, and I'm going to call this login failure. And the important part of this is to set it as an error type, okay, because this will automatically conform to the error type built into Swift. All right, so now we need two cases in here, and one's going to be for an invalid username, and the other case is going to be for an invalid password. So common scenario on the internet and in apps is to have a user log in to a system, so they need to have a username and a password, and that would generally be stored in a database of some sort. And what we're going to do is we're going to create a mock database, which is just going to store one user's details and specifically just their username and their password. So we're just going to create constants for that. So we're going to say let db username, and we'll make that user1. And we're going to say let db user or db password, and we're going to set that equal to pass1. So now you got to use your imagination. This is stored in a database somewhere. Okay, so the first thing to try to handle this error is to make that login failure error type enumeration, which we've done. So now we're going to create a variable called login error, and we're going to make that of the type login failure. And I'm just going to initially set this as the invalid password type. This way it's automatically invalid. So unless it checks through our function, it's going to be invalid. So now we need to create a function that could possibly generate an error. And when we say that it could generate an error, we use the term throws. So it could throw an error. So we're going to create a function like we normally would, with one simple distinction. So we're going to create this function called login user, and it's going to take a username, which is a string, and it's going to take a password, which is also a string. Now here's the keyword throws right there. We have to say that it's going to throw, so that throws an error. And this is also going to return a Boolean, so if the user can log in, it's going to return true. We open up our function, and now there's a couple things that we want to do here. First, we want to check the database for the username, see if that exists. And we also want to check the database for the password. Okay? Because we need to make sure that those details match. Okay, so how are we going to check the database for the username? Well, we're going to use a new syntax that's introduced, and it's the guard syntax. And basically, it works similar to the if-let syntax I showed you earlier, but it goes like this: you say guard, and then we're going to say the username, which is what the user is entering, or we're actually entering through the function, and we're going to say that that has to equal our DB username. And if that's the case, we'll let that go through. Otherwise, we'll say else. Then what we need to do is we're going to do two things. We're going to set our login error to the correct error. So we're going to say login error dot login error, and we're going to set that equal to a login failure dot invalid username. And then what we want to do is we want to actually throw that error. So we're going to throw login failure dot invalid username. Okay, so in other words, what this syntax is saying is if the username is equal to the database username, we're good, continue in the code. And if it's not, then we got a problem and we're going to throw this error. Okay, so let's just back this up one notch here. So now we need to check for the password, and we're going to do that the same way. So we're going to say guard password, and if that can equal the database password, then we're good. Otherwise, we need to set our login error equal to a login failure dot invalid password, and then we need to throw that error. So we're going to throw our login failure dot invalid password. All right, now outside of these guard statements, if they can get through that code, then we're going to return true, which means that everything is good. Go ahead and log the user in. So right at this point is where we would have the code to go ahead and log user in. Okay, now that code's not actually going to exist in this playground, but we would log the user in. Now, how do we do this? Is the same way we would do any other function, is we would just run the function. So we would call login user, and we would put the details in, but we're going to get an error here. So even if I try this the correct way, and I do user1 and pass1, you'll notice that I get an error, and the reason is because this function can throw an error, but we're not marking it with the try statement. So we can't just do that. We need to use what's called the do try catch statement. So basically, all that is we say do, and we open up a code block, and then we say try, and then we do the function. So login user, and then we'll put the correct details in here initially. And then what we need to do is put a catch statement here to catch the errors. Now in this catch statement, we're actually going to switch on our login error. So we're going to say switch login error, and we need to do a couple things based on what the login error actually is. So in the case that it's a dot invalid user name, I think we said, let me just, yeah, invalid username. Then what we're going to do is we're going to do a print statement, and we're going to say that login failed, invalid username. All right, and then in the case that it's dot invalid password, then we're going to do the same thing. We're going to do a print statement, and we're going to say that the login failed, invalid password. All right, so those are the only two cases we have, but it's sometimes a good idea to go ahead and also put a default case here in case there's an error that we didn't predict. So we could actually put a default case here, and we'll do a print statement, and we'll just say, because we don't know what happened, an unknown error occurred. That's not required, but actually what's my, yeah, it's never going to be executed because there's only two statements on our thing. So yeah, if we had not used a enumeration, then that would have been a good idea. But since we did use an enumeration, we actually doubled up on what we needed. So right now the user's logging in, and it's saying true over here because the user can indeed log in. But let's say that the username is incorrect. So I change that. Now we have login failed, invalid username. So let's put that back the way it's supposed to be. Now they can log in. Everything's fine. But let's say they tried pass 2. So now the login is failing because of the invalid password. So you can see how this can actually handle your errors quite elegantly, and your code is safe. So this true statement will never be reached if the username or the password is incorrect, because we are doing a do try catch statement down here, and this is all this code here is bundled together. So this enumeration works together with the login error and together with the login user function, and the way we actually call that function is what handles the error here. So as you see, that's a very nice way to make sure that your user indeed does have the correct credentials to log into your system. So error handling in Swift, it's pretty nice. It's pretty extensive, but once you get the hang of it, you're good to go. So I would suggest that you play around with this a little bit. You know, try to make your your own login system, your own fake login system in a playground anyhow, and then move on once you've got a handle on error handling. All right, so we'll see you in the next video. Okay, so we're going to talk about property observers in this video, and specifically getters and setters. And getters and setters are important because they allow you to basically synchronize two variables and synchronize their values so that you don't have to manually update it all the time, which is great because that's less work for you. So less work for you means less work for you in the code, less coding, and less time developing. All right, so
let's get on with it and get into a playground. So the cool thing about property observers is that you can set one variable and have another variable set at the same time. So you have two variables and you only set one, but it updates both. And let me give you an example. Let's say you had a variable for feet and you wanted to also keep track of the number of inches. So you can do that with a getter and a setter. So let me show you that because that's a really good example. So if we create a variable called feet, or actually we'll create a variable called inches, and we're going to say that that's a double, and initially we're just going to set that to 0. Okay. Then, now here's the important part that you got to watch out for. Now we're going to set the variable for feet. So we're going to say variable feet, and we need to specify that that's also going to be a double. And then we open a code block. So this is sort of like a closure, and closures we haven't got into, but we'll get into those when we do talk about actually creating apps, because we will see those in frameworks quite a bit. So now inside this code block, so to speak, what we do is we say get, and after that we can optionally say set. Okay, now inside these get and set blocks is where it actually does the work. So the get block is going to get the value for feet. And how do we get the value for feet? Well, all we're going to do is we're going to return, and then we'll just put this in parentheses. We're going to return inches divided by 12. Okay, because there's 1 foot in 12 inches. So now if we wanted to set something, so now we're going to set inches off of the value of feet, then we would just say inches equals, and there's a important variable here, and it's called new value. So it'll be new value times 12. Okay, so now let me show you that this actually works, because right now we have inches set at 0. So if we call up feet, what do we have? 0, which makes sense. So let's set inches up here to 12. And it comes up with 1 feet. 1 feet. 1 foot. And if we set it to 18, then it comes up as 1.5 feet. So as you can see, and the same occurs in reverse. So if we don't set this to any value initially, initially if we don't set that, it's going to cause a problem with our getter and setter. So we can reset it down here. If we say that inches now is, instead of being 0, if we set inches equal to 24, then you'll see that our value for feet is 2. But if I set feet equal to 3, then it's not going to update here because this is before the playground. Okay, but if I look at it further in the playground and I look at inches and I just literally pull it up, then that will come up as 36 inches. So they're setting each other based on what the latest value of one was. So the latest value was that feet is 3, so inches must be 36 based on the code that we've given. All right, so hopefully that makes sense. And I'm going to give you another example though. So in this case, and we're actually going to build a calculator in the course. So in this case, we're going to have a display, and the display has to display a string. Okay, so we're going to create a variable for the display, and we're going to set that equal to what a calculator normally would show when you turn it on, which is 0. But now, in order to actually do the math behind the scenes, we need to have that display value as a double so that we can actually work with it with mathematics, because you can't work with a string in mathematics. You have to convert it first. Okay, so we're going to have that done automatically. So we're going to create a variable called display value, and we're going to open up a code block, and we're going to make a getter, and we're going to make a setter. Okay, so first, to get the display value, we also need to specify what type this is. So make sure that we do end up specifying the type. So for the display value, it's going to be a double. Okay, and what we need to do here is we need to say first, in order to get the display value, what we want to do is we want to return the double version. So I'm going to type double in there, and then inside I'm going to say display. And I know I said this was dangerous before, but we need to specify that that definitely has a value. Okay, so now in order to set it, what we're going to do is we're going to say display is equal to the string version of new value. All right, so let's see how this is working. Let's first give us some room here so we can see. But if I set now display equal to a string, which it has to be in order for us to actually display it. So if I set that to 789, and then I check what display value is, it's 789 as a double. So as you see, that works perfectly, and that eliminates so much work in the process of creating a calculator that literally pays for itself. Okay, so you can get these for like 99 cents. No, I'm just kidding. But literally, taking the time to do this one time rather than doing all these conversions like this throughout your code is really worth your time. So I suggest that you take a look at these examples, come up with examples of your own, like converting Celsius to Fahrenheit or feet to meters, things like that, and really understanding these, because these are very important, getters and setters. Okay, you will love them. We'll see you next video. Okay, so in the next few videos we're going to talk about classes, and classes are extremely important, not only in Swift but in any object-oriented programming language. And classes really they make up the framework and the substance of what your program actually is and what it does and where you hold all your functionality, and it's where pretty much everything happens within an application. So this is really important to grasp, so we're going to take it kind of step by step. This particular video, I'm going to introduce you to the class structure, and in fact you've seen a class because we did the quick demo where we used a class file, but I'm going to explain it to you in more depth here, and we're going to get rolling with classes. Okay, so let's head over to a playground. So classes, very important to understand. So let's first define a class, and you do that with the class keyword, and then you give it a name. So we're going to create a class called car, and notice that I'm capitalizing that, okay, because that is the naming convention for classes, or that you capitalize them. Now if a class does not inherit from anything, then you just open your code block, give yourself plenty of room, and you write your class. Now class files are generally stored as a separate Swift file, so each class would have its own file. It doesn't have to be that way, but generally that's the way it's done, and that's the way it's recommended to be done. So classes hold certain things within them, and one of them is properties. Now what properties are just variables. So for a car we would have things like make, and I'm just going to set all these to an empties. It would have a model, for example. You might have mileage, and I'll just set that to 0 right now. And it also would have what are called methods, and methods are just functions. Okay, so it would just be a function. So we would create a function, and here we'll just call this description, and it's not going to take anything, but it is going to return a string. And we'll open up our function, and in this function we're just going to return a string, and our string will say the make and model has, and we'll pull out the mileage, miles on it. So that's it. That's our function. That's our description function. And inside of a class, we refer to that as a method. Now also, classes, in addition, have initializers. And initializers are basically what allow you to set these variables as you're creating a class or as you're creating an instance of a class, because we call objects in Swift, we call them instances, because objects can be either structures or they could be classes. So rather than differentiate, we just say instance of. So you have initializers, which would set it, and initially in this one I'm not going to set any initializers, and you could have a custom initializer, and I'm going to go over that in the following video. We're going to continue on this same playground. So at this point our class is created, and now we have this nice nifty car class. Now one thing to note is that this car class is not inheriting from anything. And in fact, it's not inheriting from any unseen file in the Swift language at all. It's literally what you're making right now. So there is no functionality in this class unless we inherit from another class or we put the functionality in the class. So keep that in mind, that there is no secret functionality that comes by just creating a class. All right? So we're going to create a variable, and we're going to call it a Camaro. And we're going to set that equal to a car. So we'll just type the word car in, and we'll initialize that with the parentheses. So now we have an instance of a car that goes by the name Camaro. Okay? So now what we can do is we can set some things on this Camaro with dot syntax. So if we say Camaro dot, and we can put the make, and the make for a Camaro would be a Chevy, right? So we'll set that, and we'll go ahead and say Camaro.model, and it's pretty obvious here, but we'll make it more specific. We'll make it a Berlinetta. Okay, so it's a Camaro Berlinetta. I don't know if you're familiar with those really nice cars. And then we can say Camaro dot and pull up the description method. You see how it has that little M there next to it? That means it's a method. So we can just pull up that method. And what it'll say over there, it says now, when we pull that method up, it says the Chevy Berlinetta has 0 miles on it. And that's because we didn't set the miles. So let's set some miles on it. So we'll just pull up Camaro.miles or mileage. Set that equal to, this pretty new car. So it only has 1,230 miles on it. All right. So, and that is basically how you create and instantialize an instance of a class. So in this case, it's a car class, and we created a car called Camaro, which is the variable name. And then we set the variables here. Now, if we had an initializer or a custom initializer on here, we could have set this all in one line, but since we didn't have one available because we didn't create one, we couldn't do that. But we are going to do that in the next video. Okay, so in the next video we're just going to continue off of this same class file, or the same playground rather, and we're going to continue learning about classes. Specifically, we're going to get into initializers and custom initializers, and we may get into access levels and stored and computed properties, because so far all these properties are stored. See, they're just a variable and they don't really do anything aside from take a value. Okay, but there are things called computed properties where you can take the variable or the property, a couple different properties, and put them together and make them another property, or you could perform some kind of function on them. And we could say mileage and plus 100 because test driving in the car lot or something. Okay, so we'll continue in the next video and continue our knowledge of classes. Now we're going to take a closer look at classes, and since we've already created a class, we're halfway there. So we just need to modify a few things. We're going to look at a bit more advanced syntax. We're still going to talk about the properties and methods and initializers and instances, but we're also going to talk about access levels and stored versus computed properties. So, and we'll also take a look at what a class instantiated with an initializer looks like versus without one. And you'll see there's a big difference, and you'll like the difference with the initializer. So we're going to take a look at that, and we'll jump back into that playground we had created in the last video. Okay, so delving a little deeper into classes, the first thing I want to do is actually what we're going to do is we're going to comment out this Camaro, and you know, it's a nice car, but it's got to go. We're going to work on a different car. So the first thing I want to do here is change this makes and model and mileage, and I want to just set those equal to a type. So the make, we're going to make a string, and the model, we're going to make a string, and oops, and the mileage, we're going to make an integer. Okay, now you notice that we're getting an error on our class here, and that's because we haven't set these to anything, but that's okay. It's going to give us a fix-it to try to set these equal to an empty string or a 0 integer, but we're not going to do that right now. Instead, we're going to get rid of that error by creating an initializer. So we do that down here where I had written initializer, only because I had written initializer there, by saying init, and we'll open a parentheses, and we'll say that this is going to have a make, which is going to be a string. It's going to have a model, which is going to be a string, and it's going to have a mileage value, which is going to be an integer. Okay, now once we put that in, we no longer have our error, but in order to actually do something with this, we need to open this up, and we're going to set some values here. So the way this works is you need to say self to access the actual car, and you'll see the term self used in Swift quite a bit. But so what we'll say is self dot make is equal to make, okay, and then we'll say self dot model is equal to model, and self dot mileage is equal to mileage. So what we're doing here is we're saying that the self.make, which is the make up here, is going to be equal to the make, which is the make that's created when the car is initialized. So when we go to create it. Now, in addition to initializers, there's also deinitializers. However, unless you're doing something extremely complex, you won't have to worry about deinitializing anything, because Swift uses what's called automatic reference counting, or ARC for short, and that means that you really don't have to worry about keeping track of memory management for these objects that we're creating. So if you're familiar in other languages with garbage collections and things like that, you don't have to worry about that in Swift. It's extremely efficient at handling memory management, so this is almost something of a non-issue for developers. And unless you're creating something that really doesn't know whether or not to hold on to the memory or not, then don't even worry about deinitializers. Once you start running into memory management problems and you're getting all sorts of debug errors, then you may need to take a look at it. But for the most part, deinitializers aren't really used in most apps. Okay, so now with this said, if we go to create a car now, you'll see what happens. So if I create a variable and I call this M300, so this is a car, and we're going to set it equal to a car. Now you'll notice when I go to put the parentheses, I now have this make, model, and mileage that it's going to ask me to enter. So I can now enter the make. So in this case it would be a Chrysler. And the model, which is pretty obvious from the name, M300. And then we can put a mileage to it. So we'll just say this has 89,000 miles. And now we have our car, which is an M300. So if we now call up M300 dot description, you'll see it says the Chrysler M300 has 89,000 miles on it. So by creating that initializer, we've easily filled in all the requirements that our particular car class needs. So as you see, the initializer, while it might seem a little painstaking, and by the way, the reason you need to say self.make equals make, because I understand that sounds redundant, but when you ask to fill this in, you don't have to call it the same thing. Like this could say make here, but it may say company, you know, down or up top, you know what I mean? So in that case it would say self.company equals make. So if that makes any sense, then you're doing good. All right, so what we want to do now is I want to talk about, just briefly, about the access levels for classes. Okay, so there are 3 possible access levels, and I'm just going to put them in a comment up here, and they are internal, private, and public. Now, as we have this class written, it doesn't say it, but the default for your access is internal. So if I were to write internal here, it would have absolutely no effect on the class. Okay, and internal, what that means is that any file within your program can access this class. All right, now if I set this to private, then what that means is that only this particular Swift file has access to this class. Okay, so that could be useful in some circumstances. And if we set it to public, then that means that anyone we share this file with, or anyone we share our code with, will be able to access this. So that would only really be useful if you're creating a framework or something like that. Okay, in general, when you create a class, you're going to leave it at internal, so you're not going to specify it at all. All right, now I did mention about computed properties, so I want to make a little space in here to put at least one computed property in here, so I show you how to do it. So to make a computed property, what you do is you create a variable. So we're going to create a variable called name, and we're going to set that equal to or of the type string, and then we're going to open a code block. So this is like a closure, and then we're going to simply return a string, and in that string we're going to combine the make and the model. So we're going to pull out make, put a space in there, and then we'll pull out model. Okay, so that's a computed property, and basically what that means is we're not asking anyone for what that information is, but in essence we're getting that information from the 2 inputs, the make and the model. So now we'll have access to a .name. So if I come down here with our M300 and I pull up the M300.name, now that on the right hand side will tell me that it's a Chrysler M300. Okay, without us doing anything additional. It's just in this 1 line of code, or these 3 lines of code, that does that for us. Okay, so I realize this is a lot to take in, classes, and I'm not going to go too much further into it because we use classes so much that by the time you're done with this course you will be an expert on classes. So we're going to move on actually, and we're going to talk about subclasses. And as you can imagine, subclasses are directly related to their superclass, which this in this case is a superclass because there is no inheritance from another class. So we would make a subclass off of this, so a type of a car, and we could perhaps make a cab or a taxi or something like that. and that would be a subclass of a car. Okay, or we could make a sports car, or we could make, you know, whatever you want. It's up to you. You're building it. So, but the whole idea is that this one doesn't inherit from anything, and our subclasses that we're going to create next will. And we're going to actually do it right with this same file. We're going to create a subclass from our car class. So we'll see you in the next video, but make sure you understand everything that's in here, even if you have to watch the video a second time, because there is a lot of information in here, and I understand it's a lot to take in. So we'll see you in the next video. Okay, so in this video we're going to talk about subclasses, and subclasses are extremely important and they're extremely valuable, and they save us tons of time. Apple and other third-party vendors have put extraordinary amounts of time and effort into developing frameworks for us to use, and by importing their frameworks and inheriting from their superclasses, we can immediately reap the benefits of all their hard work without us having to lift a finger. So instead of inventing the wheel every time we go to do something, we can inherit from a superclass and immediately have all sorts of functionality within our program. So this is definitely the way to go when you program, and in fact you'll see that just about every class that we have in an application inherits from one or another superclass, so or more, and we're going to need to understand exactly what's happening behind the scenes when we do that. So let's take a look in a playground and we'll investigate subclasses. So as you can see here, I have a version of our car class here, and it's slightly modified so that it acts more like a superclass, because a superclass in general will not have a custom initializer. Those are generally reserved for the subclasses. So I went ahead and I took that out, and I set these to empty strings and 0 values for the integers, so that we could go ahead and actually create this as a subclass should be created, because the car class really shouldn't have any custom modifications to it, but a subcar should. So if we go ahead and we create what's called a police car, so we'll make a class for a police car, and to make that inherit from the car class, we just go ahead and make that of the type car, and we open it up. Okay, and then we can put our code right in here. But before we do that, I just want to show you that if we go ahead and make a police car, so if I make a variable and I call that cruiser1, and I set that equal to a police car, when I go ahead and try to instantiate that, you'll notice that nothing is there. And you may be wondering why we're not getting that functionality from our initializer, and that's because I removed it. So at this point, we would just create a regular police car, and then we could set the properties in the normal way. So we would say cruiser1, and then use the dot syntax to put mileage and the make and whatnot in there. Okay, so if we make the make a Dodge, we'll say, and then we'll make cruiser1 model equal to a Challenger, and then at this point we should be able to call up our description. I think we may have missed putting the mileage in, so let's do that. So we'll set that equal to 90,000, and then we can call up our description, and it'll go ahead and say the Dodge Challenger has 90,000 miles on it. So we're inheriting this method, we're inheriting all these property values. So at this point you may be wondering why we would go through the trouble of making a subclass, because there's nothing different. And the reason there's nothing different is because we have yet to add it. So there's things about a police car that are different than a regular car. So we could say put new variables in here, new properties. So we could say a variable cruiser ID, and we'll make that an integer. And then we could say, you could add as many different ones as you wanted, but the whole idea is then you would want to make an initializer, and then you would have our cruiser ID in there, and that would be an integer. Oops. And then we would open up our code block and put our code in. So it would say self cruiser ID equals cruiser ID at the local level. Okay, that's one thing we didn't talk about is scope, but we'll get into that when it becomes relevant. So now that we've done that, though, that invalidates our police car declaration here, because we need to put a cruiser ID in there. It says that when we initialize it, we're going to have a cruiser ID. So if we just back this up a little bit, we can add that in here. So cruiser ID, and we'll just say this is cruiser ID 45. Okay, so then we can add cruiser ID 45 in here if we wanted to, and we could pull that up. And I'm not going to spend too much time on subclasses because we're going to go into such detail in subclasses. I mean, literally everything we're going to do in the class or in the course is pretty much going to be dealing with subclasses, and as we go through it, I'll be explaining it in much more detail. So just so you understand how it inherits from there, from the superclass down to the subclass, I just wanted to give you this quick example and how you can add methods, and you can add, we could change this description, in fact, if we wanted to. So, and we'll get much more in depth in this when we start creating our apps. Okay, so this is just the tip of the iceberg on subclasses, and that's it. We're going to move on to structures from here. Okay, so in this video we're going to talk about structures, and in a lot of programming language, structures are limited to very primitive value types, and they can only do so many things. And in Swift, that couldn't be any more different. Structures are actually just as powerful as a class, with a couple key differences. One of them being that structures cannot inherit from another structure. So there is no inheritance when it comes to structures. So structures, you can create instances of structures, but you can't create a substructure from a structure as you can in classes. So, and there are a couple other differences, and we're going to go over them in detail in the playground. Okay, so as you may be able to tell, I have a class in front of us, a person class, and it has some properties. It has a couple computed, or one computed property. It has a method, and it has an initializer. And you may be wondering why I have a class up here if we're talking about structures. And the reason is that structures actually support everything that classes do in regards to what I have on this screen. So they support properties, they support computed properties, they support methods, they support initializers, custom initializers. And in order to make this into a structure instead of a class, literally all we need to do is put the struct keyword here instead of class, and now we have a structure. And if I were to create a person, so if I were to say variable Jason, and I'll make that a person, and to instantiate that, you'll see I have, you know, our custom initializer there, and I can go ahead and put the details in here. So I could say, you know, the name, first name, I could say the last name, I could say the age, completely incorrect by the way, and with that you'll see that oh, I have an error because I put that as a string, and it's just an integer. So that's we'll make it a little closer to the truth. Okay, so there you see that I can now also pull up JSON.description, and that will go ahead and type out the description on the right hand side. But there's something about structures that is even more interesting, and that's this initializer here. So I'm going to just delete what I wrote here for a second. I'm going to delete that completely. And the thing about this initializer is we really don't need it in a structure. So if I go ahead and delete this initializer, then it's a little bit more compact. And when I go to create Jason again, you'll see that if I make him a person, I have an empty person, or I have this person here that I can create
that has what's called a convenience initializer. So with this convenience initializer, I don't have to go through all the hassle of putting in all the initializer code. I can just put in my properties, put in my computed properties, put my methods in, and then everything will work, and I'll get this convenience initializer that is really, really cool. However, that may be cool, but there are downsides to structures, because at this point you're probably wondering, well, why don't we just use structures instead of classes, because then we wouldn't have to worry about initializers. And the fact is, in general, you don't have to worry about initializers when you do classes or subclasses anyhow. For the most part, it's really an optional type of thing. They don't need initializers. Of course, if you set something that has a no value to it and it just has a type, then you need to put an initializer. But why would you decide to use a structure versus a class? And a structure, I would say, in my regard, you could use a structure for holding data types and, even complex data types, even objects, and obviously we can instantiate different structures, and a lot of developers use structures to go ahead and they make one structure file and it literally hold all the variables for their program in there, so they can just refer to that struct and be able to call up any variable that they'd like, which is really cool. But as I said, you can't go ahead and say that this person inherits from someone, because there's no inheritance involved when we talk about structures. So you can't inherit. So that's one huge downside. Now the other difference between structures and classes are their value types, basically. So a class is passed by reference value type, whereas a structure is passed by value reference type. So what does that mean? Basically means that when you have a class, it refers to the class for any set properties or anything like that. When you have a structure, it copies that at the time that you instantiate it, and then if you go ahead and change the structure later, that won't have those properties in it. So if that makes sense to you, then you're doing good, because that's a hard concept to grasp, and you'll understand it a little better once we get more involved in actually coding things. But the reason why you might choose structure over a class is this convenience initializer is really cool, but it does come with drawbacks. You can't do any inheritance, so you will see most of the code done in Swift in classes opposed to structures, even though structures are theoretically just as powerful. They just can't use inheritance. Okay, so just so we're clear on that, that's the big difference, is that they can't use inheritance, and the other difference is that they're passed by value opposed to passed by reference in classes. Okay, and I'll have more details on that later in the course, so don't get too hung up on the pass by value, pass by reference thing just now. But just know that it will, become ultimately very clear to you by the time you complete the course. And structures, as you see, very similar to classes. They can do just as many things as a class can do, but they can't inherit. So we're going to move on, and we're going to talk about NSUser defaults, which is actually a part of a framework that helps us store data persistently that will, persist through a shutdown of the device, and the data will still be there. So, okay, so in this video, I just wanted to give you a brief look at NSUser defaults. And NSUser defaults allow developers like you and I to save data persistently to the device that will, in fact, be there through a device reboot or a device shutdown or a system failure or a battery drainage, and the information would still be there. So in other words, when you normally store a variable, what happens is it's there, it's in memory, but once it is out of memory, in other words, the program is shut down completely, not just in the background, then those variables would be lost. unless we use some type of saving mechanism, such as NSUserDefaults or core data, or saving to a plist file or a database or something like that. So I just wanted to touch on that and give you a brief look at how that's done, because we're going to be using that in quite a few of the apps that we do. Okay, so we're going to jump into a playground and we're going to take just a quick look at NSUserDefaults, and then we're going to get into more interesting stuff. Okay, so to access NSUserDefaults, we actually have to be in one of the frameworks like UIKit or even just Foundation. So we need to import a framework here, and we could import UIKit, or you could import just Foundation, which Foundation is in fact within UIKit, so either way you're going to get it. So what I would normally do when I want to save something persistently is I create a variable, or a constant rather, and I call it defaults. And that reasoning for that is because it's NSUserDefaults, so it's easy to remember. And I set that equal to NSUserDefaults dot standard user defaults, and that sets a memory location basically in the NSUserDefaults system. So NSUserDefaults will store data persistently, and I explained that at the beginning of the video, but it's useful probably to repeat it because it's important enough for a developer to understand that they need to save information from a user, because if a user isn't able to go ahead and save their name, or if your game can't save a high score or anything like that, then chances of that being seen as a valuable app is kind of diminished. So basically what we would do is, if we create a variable and we say name, so this would be the user's name, and we ask for them to put that in, and they go ahead and put that in, and that name is Jason, and then we want to store that persistently. Then what we would do is we would access our defaults, and we would say set object, and now what this is doing is setting the object, and the object is actually the variable, so in this case name, and then we set a key for it, and the key is a string, and I try to keep it simple, so I set it as name, and that sets it in the system as NSUserDefaults. Now there is something called synchronize, so you could do defaults.synchronize. However, it's not really necessary unless you're doing a lot of changes to your NSUserDefaults within the same function or something like that. In fact, Apple recommends that you not use this command because it's not really necessary. Okay, and in my estimation, I agree with that it's not necessary. But in order to go ahead and pull this information back out, then we would need to go ahead and set that to we need to find a way to pull that information back out. So the way we do that is we go into our defaults again, and we set string for key, let's say, because this is a string and the key is name. Okay, now if I do that, that's coming up nil right now, but the reason for that is because we're in a playground and it's not really the optimal place to show this, but I wanted to show you at least this one line here at the very top, because it's important that you understand how we access NSUserDefaults, and we're going to get into a lot more detail about this, but for right now this is good enough. I just wanted to let you see that syntax basically. So as long as we're in one of the frameworks, whether it be UIKit or WatchKit, it has access to NSUserDefaults, and we'll be using that extensively. Actually, we'll use it with suite names, and we use it so we can save data between the iPhone and the watch, and in fact you can save data using NSUserDefaults between different applications, so that's why it's useful. So you could actually in fact save the username, and then when the user logs in with another application of yours, you could have their name already there, and that would be pretty cool. So at this point I want to stop, and we're going to stop going over basic Swift, and we're going to go into some of the UI elements of the watch, and we're going to look at some of the user interface and the way the user interacts with the watch and some of the elements, and we're going to start really getting into the meat of Xcode, So I want to congratulate you on getting this far through here, and I don't want you to spend too much time. And the reason I was brief in a lot of these sessions is because I don't want to overload you with the code. I want you to get to the fun stuff quickly, and we're going to explain it as we go along even further, okay? So don't feel like you can't continue if you haven't memorized everything, because it will be reiterated and re-emphasized to you throughout the rest of the course, okay? So congratulations on getting here, and I look forward to seeing you in the rest. All right?